Hello, in this video we're going to look at the properties of segments that intersect inside the circle and outside of a circle. Let's jump in and take a look at this first problem. So in this problem, the segments intersect inside of the circle, and when that occurs, because of a concept of similarity in triangles, we get this equation that says one part of the segment times another part of the segment, so like this part times this part, is going to be equal to part of the other segment times the other part of the other segment. So this part times that part. The key thing here is that the parts are broken up over the same segment. So what we end up with is this equation. We get 9 times x is equal to 6 times 6. And from there, this just becomes an equation that we can solve. So this side becomes 9x, and this side becomes 36. Then we're going to divide both sides by 9 to get that x is 4. So that is the basic concept there. That's really all we need to do with this problem. They can make the problem harder by throwing in quadratics or making you solve for a piece instead of just the x value, like how long is this line? Something like that, but that's really the only way they can make the problem harder. Let's take a look at the next one just to make sure we really get it. So this one, the vertex again is in the center, so we're going to use the same equation. We're going to take this part of the line times this part of the line, so 15 times x minus 6, and we're going to set that equal to this part of the line times this part of the line, 9 times x minus 2. Again, key feature, the parts that we're multiplying are on the same chord. So now we just need to multiply all this out. We're going to distribute here. This is important. A lot of people forget to put those parentheses around, and then they forget to distribute that 15. So make sure you're doing that anytime you input a binomial into your equation. We're going to get 15x minus 90 is equal to 9x minus 18. Now from here we just need to solve for x, and we get all the x's together. Something you don't really want to do in real life. Cancels out, you get negative 18 on this side, and on this side we get 6x minus 90. We're going to add 90 to both sides, and we'll get 6x equals 72, and then divide by 6 to get x is 12. And that's it. That's our final answer. All right, so that was inside the circle. Let's take a look at what happens when our vertex is outside of the circle, like in number 3. So we still have an equation that applies to this, but this equation is going to be a little different. And the way this equation works is we say the outside piece of the line, so if we're looking at this top line, the outside piece is 9, so outside times the whole line. So what we have to do is look at what is this whole line here. And so if I wanted to find the whole line, I'd have to add the 9 and the x together to get x plus 9. So the outside times whole. And that's going to be set equal to the same concept on the other line. Outside piece is 10. Sorry, set equal to the outside piece, and then we're going to multiply that by this whole line, which would be distance from here to here, so that would be 10 plus 8, or 18. And so that's what we would put in our equation there. And so we get this equation, 9 times x plus 9 is equal to 10 times 18. And so now that we have that, all we have to do is solve this equation. So I'm going to distribute the 9 to both of those, and I get 9x plus 81. And then I'm going to do 10 times 18 and get 180. Subtract the 81 from both sides, and get 99, and then divide by 9 and get 11. And that is our final answer for that problem. So key thing here is we remember to do the whole line here and not just the inside. That's the common mistake on a problem like this. Let's look at one more. We're going to skip that one. We're going to actually look at number 6 here. So number 6, same type of problem. We ask our is going to be outside of the circle. So we know the equation is outside times whole equals outside times whole. So now we just need to find those pieces. So what I do first is I'm going to identify the outside piece of one line. So that's the outside there. And then I'm going to go back the whole line. The whole line is from this point all the way to that point. So that whole line is going to be 8 plus that 2 plus x, which gives us a final of x plus 10. So that's my whole line. So let's write that out. We got the outside piece of 8, and we're multiplying that by x plus 10. Then we're going to set that equal to, and go back to our other line. The outside piece of this bottom line is 7. And then the whole line, we have to add up both those pieces. So 7 plus x plus 6, it's going to give me x plus 13 for that whole line. So I'm going to write 7 times x plus 13. Now from here, it's just solving the equation. We're going to take 8 and distribute it. We get 8x plus 80. And this side we're going to take and distribute the 7 and get 7x plus 91. From here we're going to solve for x by subtracting 7 from both sides, or 7x from both sides. Now we get x plus 80 equals 91, and then subtract 80 from both sides and get x is equal to 11 as our final answer. Okay, so now there's one other type of problem I want to look at, and it's really the same problem. It's just your setup could be a little different. So we're going to scroll down to problem 8 here. Now the vertex is still outside. So I still have that equation outside times whole equals outside times whole. I still have that, and it's still going to apply, but something changes here. So let's take a look. The outside piece of this first line is 4. The whole line is 4 plus 5, or 9. So that's going to be 4 times 9. Now if we look at the other line, the outside piece is x, so it's going to be equal to x, the outside, but the whole line is also just x. We're going to be multiplying by x. Now we can sometimes see this equation written as 4 times 9 is equal to x squared, because we know since the outside and the whole are the same, that's like saying something times itself or squaring it. So from here all we have to do is solve. So we do 9 times 4 and we get 36 equals x squared. Now to get rid of a square, you take the square root of both sides. And when you take the square root of 36, you get technically plus or minus 6. But because it's an application in terms of distance, we're just going to have that positive 6 for our answer because we can't have a negative distance. Okay, so that is really the different types of problems you can have with segments inside the circle crossing and outside the circle crossing. And here are the rest of the answers if you want to check those out. In the next video, we'll be talking about tangent lines and the properties that they have.